Good afternoon, everyone. We're just about ready to launch our session entitled International Space Cooperation. And my name's Michael Davis. I'm currently the chair of the Andy Thomas Space Foundation, so it's a great privilege to actually chair this session. And our two distinguished experts, Dr. Jane Kaczmarek, Senior Operations Scientist with the Square Kilometre Array Observatory. I was almost about to say the Square Kilometre Array Organisation, but Jane, in a very timely way, corrected me. It's the Square Kilometre Array Observatory. And our other distinguished expert is Professor Robert Sharp, who is Head of Instrumentation Research, School of Astronomy and Astrophysics at the Australian National University. So I'd like to start by inviting both of you just to tell us a little bit more about what you do and why you've agreed to speak on this interesting topic of international space cooperation.
Can I turn the microphone on? Yeah. Start with an apology. I've had a stinking head cold all week, so I'm going to be a little bit nasal. And I'm also English, but I can't do anything about that. I'm an astronomer at Mount Stromlo Observatory in Canberra at the ANU. My day job's measuring black hole masses and looking at the evolution of star formation across cosmic time. But in order to do that, we have to build our instruments for the telescope. So I'm head of the instrumentation group at Mount Stromlo. We have a turnover of about $10 million a year at the moment, building instruments for small-scale research projects covered by government grants, all the way up to sort of $50 million facility pieces with 10 to 20-year lifetimes on major observatories. So we're working with the Giant Magellan Telescope, which is a largely American collaboration, but Australia is a 10% partner, building 2 instruments for the telescope, about $50 million budget over the next 10 years. And then we're also heavily engaged with the European Southern Observatory in Europe, building instruments for the very large telescope and hopefully the extremely large telescope, which we'll be building in the next decade.
And hi, everyone. I'm Jane Kaczmarek. So I am the Senior Operations Scientist at SKAO. So the SK Observatory is is built up of 20 member countries with a probably combined building and operations budget of near €3 billion. This is the largest, well, it's on the scale of the LHC. This is one of the largest multinational science experiments that is happening right in our backyard in Western Australia, where half is being built square kilometre array low. So one of the reasons that I am here is as Australia is part of that 20 member countries, there's another 8 African countries that are contributing to the build of the other half of the SK, which is SK Mid in South Africa. And there are 30 countries that have contributed to the overall design of this telescope. We are aiming to answer humans' oldest questions. So the only way we can do this is by working together across multinational institutes, organizations, and research infrastructure to kind of achieve this, well, once-in-a-lifetime kind of opportunity to be able to do these really groundbreaking research. But that also means that we need to cooperate with space, because that has changed quite a bit in 60,000 years since we've started looking up. So it's really important that we nail that collaboration now in order to build it continually into the 50-year operation life cycle of the SK Observatory.
International organisations take time to assemble. I think that's probably a reasonable summary. How long did it take the SKAO to actually be formed? Who were the driving forces behind it, and why have you been so successful in finding so many international members?
That's a really good question. Oh, multiple questions. So the SKA idea is older than I am, in that I feel like every time I go to a different conference, people will say, well, I was at the first time that it was discussed. But the real first seminal paper, I should say, probably came in 1994, so I was around for a little bit. But one of the reasons, you're absolutely right, it takes a very long time. The idea has changed and evolved, but astronomers are really good with being patient, I think. We know that we say 5 years and it will take at least 3 times that. So that idea, the science cases are what really drives our telescope, the design, the use, and the actual involvement and engagement across the global community. So I think because that hasn't died down, things like Hubble, things like JWST, other really big successful projects have made sure that there's a continued interest in future big projects, because once we're able to do what was once thought impossible, we realize that we can kind of scope further. So some of the major drivers in keeping these large projects going are not only the international unions that we have amongst astronomers and amongst other physicists, but also being able to carry that idea into industry engagement. Because there's been a lot of perks that have come out of the SKAO, which is being able to have, at those 20 member countries, the types of businesses that have had to spin up relatively fast a kind of crazy idea with a very deep level of understanding to deliver this project. And one of the reasons we have so many member countries is that they are able to engage and get those contracts from the early days. And we're talking about, I didn't mention this number earlier, but for the SKA Low, the telescope that's being built in Australia, there will be 131,000 antennas. And with that goes all of the coax, the fiber, the power, etc. So it's a big opportunity for industry. And the science and industry together, I think, is what really has carried it along this long.
Robert, to what extent does your day-to-day work involve international cooperation?
Well, I think one of the reasons we're being quite successful in astronomy in Australia is firstly, people like it. It is a bit of a gateway drug for science. You know, people are always prepared to listen to me talk about black holes in a way that isn't always true in other science. So it gets people involved. But of course, the problem is that these sort of commitments for overnight successes take decades and decades of investment to make them happen. And Australia has been very, very good at being at the forefront of some of these investments for long periods of time. So we're currently world leaders in things like adaptive optics. That's absolutely critical for things like satellite tracking, debris tracking, laser communications. So we were already there when industry decided that was a thing we needed to start investing. My group works with high performance sensor arrays, visible and near infrared technology. It's the same sensors that get used for remote sensing. It's the same technology that gets used for remote sensing. And so it turns out, you know, optics is optics. It doesn't mind if we're looking up or we're looking down. So we're also working in remote sensing applications using these same sensor technologies. And being at the forefront of that industry, initially as scientists, you know, my day job is measuring black hole masses, but working with these technologies means that we are able to find applications outside of pure science to convince the local industry to keep supporting us, and also deliver outcomes that just matter on an international stage. And so our partners are keen to work with us because not everybody can do everything.
When I was more involved in the politics of the space industry, it was almost an accepted norm that our astronomers were far more successful in achieving their strategic aims than the rest of the industry. And I think your answer hints at some of the reasons why. Would it be fair to say that one of the reasons why our astronomy community has been successful and supported by government is that geographically we have advantages that no other country has in terms of the large share of the planet that we occupy, and also in the case of the SKA, the ability to have a very wide field of equipment in a part of the country with low radio frequency interruption or disturbance.
Yeah, I think there's two things I'd like to comment on there, but please do not think that the astronomers are the most organized community. If so, good luck to us all. Although I will, and I've heard something similar previously, in the Australian Decadal Plan, which is something that the astronomy community has been doing since the 80s, is something that has led the way for other science-focused and industry-focused groups to present to the Academy of Science. And so we've actually just released our next Decadal Plan last week. So that is something that has matured and also brought a lot of the other science community along, but it means that we speak with one voice. There might be grumbling in the background, but the astronomy community tries to speak with one voice in Australia, at least in those kind of 10-year intervals. But you're also absolutely right. When it comes to ground-based astronomy, I mean, hopefully everyone in this room appreciates how beautiful the night sky is here in the Southern Hemisphere. And that is a strategic location for people that want to study the universe. Now, people who are in optical, where you often have telescopes globally, you might be a little less necessary to be in the Southern Hemisphere. But for radio astronomy, it is absolutely the best place to be. And I do not think that it is too much of a stretch to say that we are very quickly becoming, if not already, the world leader in radio astronomy, partly because of our just serendipitous location and the galaxy overhead.
Well, certainly for ground-based optical astronomy, we don't have a big enough bloody mountain. So I have to go to Chile and Hawaii for most of the work I try to do. But I actually think the geographic advantage, certainly currently, is different there, is that Australia is so big that we've been users of remote sensing data for years, and not just users, not just taking what's available, but really driving the utility of it. The remote sensing community in this country is absolutely huge. But as a user community, and as we move into an era where the US and Europe and other institutes are starting to push looking for more investment in delivery of those capabilities. It's a thing that certainly my groups are trying to get more and more involved in, is delivering Australian services to play into that geographic advantage of having to use the data, which means we already have a power user community. We just don't have quite the capability yet to generate the data ourselves.
So we've talked about why Australia's involved and what our strengths are and what our advantages are. Can we talk a little bit about your international partners from the Northern Hemisphere, largely, not exclusively, but a large number of them, with much smaller footprints on the globe? What type, can you give us examples of the sort of the importance of cooperating with all of those other countries, and examples of the sort of things that they contribute that we need, or that the global community needs?
Yeah, so it's scale and scope. So the days where we were doing the sort of science that's world leading with small telescopes in our own institutes, they're largely gone. The GMT will be a $2 billion facility when we get it up and running. The new European facility is a similar sort of cost. James Webb, producing some fantastic results, $18 billion, I think, price tag in total. You can't do that on your own. No country's got the big enough science budget to do that. So it's international collaboration in order to deliver the scale and scope of the facilities we need.
Can you give us an example of how that cooperation works on a sort of a day-to-day basis? An observatory in the Northern Hemisphere receives data or receives images. How do they share with that, or how does the cooperation work?
Look, it's got to be based on trust. You have to trust that not everybody's got everybody's best interest in mind necessarily, but that everybody trusts the other partners to allow them to do their component of it. Having rules, that matters, putting the rules down early. We haven't built GMT yet, but we've set the policy for data access 10 years before we've put the mirrors together, so that people know what's coming. They know how it's going to work. We trust this is how it'll operate, and this is indicatively what the return will be. And because as astronomers, we've been doing that for many, many decades, I won't say it's easy, but we're starting from a position of strength. The arguments are about the detail. They're not about the basic principle anymore.
Yes.
And I could add to that in the SK's perspective,
Yes.
when you consider all the member countries, it's about 40% of the global population is tied to one of these countries and has access to, well, in theory, has access to the science and the technology that we will be delivering. But it's absolutely right to say that the day of individual country or individual university or research institution projects for big impact, those days are gone. So in Australia's perspective, we might have the land, but we don't have the capital. And something that is the scale of the square kilometre array needs to have that additional buy-in from many members from Europe as well as North America and China and Japan, South Korea, etc.
Just add to that as well. So, Chile does very well out of astronomy because it owns the Andes, or at least a big chunk of it, and that's where we put our telescopes. But it probably doesn't achieve as much as it should do, given it's where most of the world's really world-class telescopes are. So it's not enough just to simply be Australia. You have to have the people, and you have to have multiple types of people. You must have the people like ourselves who want to do the science, to drive the program, to do things that are too hard. But you also have to have the people who know how to actually screw it together.
Does Chile own and operate all of its own telescopes? And
I don't believe it owns a single telescope. It just charges a 10% tax for owning the mountain.
Right, so it gets a fee for allowing other countries to use them.
But I mean, we heard a lot in a previous session about return on investment. It's not getting a great return on its investment because it doesn't really invest anything. It just owns the mountains. Right. So you've got to ensure that you've got the local, call it infrastructure, but I mean engineers. I mean talented data scientists. I mean end user community who knows what to do with it and how to market it to other people. I'm not seeing many astronomers in the room, but you're all listening to us bang on about it.
But in the case of Chile, that expertise comes from other countries.
They import a lot of it. I won't say all of it. I mean, they have some talented people there.
Right.
And I'll contrast that for SK Low and SK Mid.
Yeah.
But in Western Australia, on Inyari Mana Ilgari Bundara, the CSIRO Murchison Radio Astronomy Observatory, which is where the telescope is being built, the construction crew are all Australian. In fact, many of the technicians that are being trained up and now training future technicians are Wadjuri Yamaji, so the native title holders and traditional landowners of that land. So we are trying to keep that investment local as part of Australia's return on investment for hosting this gigantic experiment. But yes, it has a 50-year operational life cycle, but we also have a 10-year construction life cycle. So that's many generations of people that we can employ, skill up, and expose to this amazing experiment that is going on in our backyard. And I've mentioned it before, but it really is a unique thing to be able to try a project of this scope, to try and answer the world's oldest questions of how did we get here? How did it all happen? And on the lands of the oldest continuing civilization. It is a uniquely Australian thing, and I think we're doing a decent job at leveraging that. And I think also with a lot of the astronomers or science enthusiasts or space enthusiasts in the room, Australia does really well with engaging and exciting the community. There's been a lot of great press that has come out recently with space, and I think we're able to take advantage of that.
Are there other technology spin-offs or spin-outs that Australia will benefit from what you both do?
Likely. I mean, so the first thing, I used to work for CSIRO. I used to be based at Parkes Observatory. And one of the newest receiver that we are currently commissioning on the telescope is called the CryoPath, the cryogenically cooled phased array feed. So phased array feed technology definitely came from the telecommunications industry. We've since turned it into a way of monitoring space, but we've also done a spin-off with something called Quasar, which is an all-sky monitor. So essentially putting these multiple beams on the sky, being able to track the brightest of space satellites. So there's plenty of opportunities like that. I mean, Wi-Fi is the standard example that people go to with radio astronomy. But there is plenty of opportunities. It's a little hard being part of an IGO to say that Australia will capitalize on a lot of it, because many of our contracts for build and the correlator, like the compute, have gone to other countries. But it will all ultimately come here, and the exposure will always lead to future building.
Yes, I mean, Wi-Fi is the go-to, right? But
I think the audience, some in the audience may not be fully aware of the Wi-Fi story, and I know it's a slight diversion from our topic, but would either of you like to explain how that came about?
I mean, basically, the radio telescope wasn't working properly, and somebody had to invent a new way of making the radio communications more stable. And it turned out that's the same problem as wireless internet. And so 15, 20 years of investment on a problem that nobody cared about other than the radio astronomers, and now we have stable Wi-Fi. But it really is that story. Is, overnight successes take decades. And you don't know what the success is going to be normally. I mean, sometimes it's a good idea when you start. As I said before, we work with high-end analog focal plane detectors, the ones that have essentially no noise and infinite sensitivity. They're not your little Sony Handycam that you fly on a CubeSat. They don't do that. But they are what NASA uses. They are what ESA uses, because they are the future. And so we're working on trying to make sure that we have Australian solutions for small satellites to do that. Adaptive optics is another example. Originally developed by the military to solve problems they knew they had, exploited extensively in astronomy to the point that it's now just routine and going to be fundamental for laser communications in order to get the data and signal rate up for interplanetary missions. So it's a very long journey, but we need stable, consistent funding to get there.
So we've talked about how cooperation works internationally. The other side of that topic is competition, international competition. Is there international competition for what you both do? Even though you may not know much about it, does it exist?
I mean, we're scientists, so you're always competing. You're competing for the money to do the experiment you want to do, and you're competing with the other group to do the experiment better and quicker than them.
Yeah, no, I'm thinking more in terms of some parts or countries in the world who are not a part of your cooperative organisations, who may be trying to do similar things.
So I can speak to that a little bit. Yes and no, as a non-answer. One of the strengths that we have with SKA is that it is so large, no single global economy can actually pull off something of this scale. So even if the world's largest global economy were to try and do this, they don't have, I mean, it's taken us 25 years, more than 25 years, to get to this point in the project of actually putting things on the ground. The amount of time that they would need to spin up would blow the project out of any reasonable budget, especially given a 4-year cycle of funding that seems to happen in that economy. But we do, I will say, instead of competition, I will say that we have relied on international telescopes that are similar to ours in order to redesign our current telescope as it is. So the first one that comes to my mind is one called LOFAR, which is based in the Netherlands. But it also is a multinational experiment that started just with the Netherlands, but then grew to include Germany, Poland, Sweden, etc. And we have that advantage of being ground-based, so they see a different part of the universe than we do. But we were able to learn from their successes and failures because they've been on Sky for about 10 years now. In Australia, we also have other precursors that we've had to learn from, things like the MWA, the Murchison Wide Field Array, or ASCAP, which is the Australian Square Kilometre Array Pathfinder, that we've needed to learn from in order to understand how we are going to work on this global scale. Because something I think we briefly talked on, one of the major challenges of having a project this large is that most of the people I collaborate with are in a different time zone, about 11 hours ahead or behind me. And so it's learning where the balance is. So I think part of that decision actually, or part of our reflection on other global observatories led to the decision of having one of our headquarters in the UK, where the majority of the investing countries have a faster access or easier communication with. Yeah. And so a lot of these things will not direct competition. We've had to let others fail and succeed before we could in order to learn what works.
Right. Just a little more to that. We're not afraid of competition. Sometimes you just have to run the other guy over. But if you've got limited resources, you're normally better off either collaborating or complementing. So sometimes deliberately don't do the thing that somebody else is doing, because it'll be better if you build the other thing. But that said, sometimes just go head to head, be there better, be there quicker. That's the right answer.
Sure. Any questions from the audience? Oh, is that because I have covered the entire topic with no gaps, or yes?
I mean, the main problem is that we collaborate with almost everybody at the moment, and they don't always play nice together. And so you can kind of get stuck in the middle. The GMT, which I'm a big fan of, I'm building one of the instruments for it. That's largely an American project, but also Korean. There's a Taiwanese institute involved, there's an Israeli institute involved, there's a Brazilian institute involved. And we're also working with the European Southern Observatory, which is none of the people I just mentioned. And so you do end up working with everybody in every time zone. The radio astronomers work a lot with the Chinese at the moment as well. They have an excellent observatory, which is highly complementary to the new facilities. So yeah, we will work with anybody, but you've got to make sure the partnership makes sense, that you know why it's a good investment. Return on investment is the phrase I guess I'm supposed to use.
And I can add a little to that as well. So from the SKA's perspective, in order to be a member, it's very cut and dry what you have to do. It's a certain percentage buy-in for the size of your population, especially your astronomy population. So in that regard, we want everyone to be members because they bring capital, and then we can build more telescopes and we can do more cool things. How long is a piece of string, we want all of it. But I do think when we start thinking to the biggest and the most exciting science that the SKA is going to be doing, global location again plays an interesting role. So the technique of very long baseline interferometry, or VLBI, which some of you may know, you actually want as long of baselines as possible, or distance between telescopes, but you need to make sure that they still can see the same part of the sky at the same time. So Australia is really well positioned to partner with a lot of Southeast Asia in that regard, whereas Europe, we can't really see the same part of the sky. So I would like to see more buy-in from countries in Southeast Asia, because then we can start building, we can actually deploy little stations there and do this really exciting science that is going to be completely transformational at the frequencies of SK low. The same would go for MID, which is being built in South Africa. So just to draw a line north, in every country that it goes to, I would love to have a baseline with. So there is that little bit of advantage, but really when it comes to who we are courting at the moment, it is anybody who shows interest, because they just bring capital so we can build.
Any more questions? No? Well, if not, I think we've exceeded our time by 5 minutes, which is my fault. But I've really enjoyed the conversation. Thank you to you both for your very enlightening and very clear explanations of what is quite a fascinating world that not many of us have experience in or direct contact with. So please join me in thanking our experts.